Okay, starting with number 3, 2x plus 5y equals 7. And our second equation is x plus 4y equals 2. And they want us to use the substitution method, so all we really need to do is choose one of these equations, solve for one of the variables, and then substitute it into the other equation. So the first part of that is finding a variable to solve for, and x would be the easiest because it's just one x. So we'll subtract 4y from both sides, and x is equal to 2 minus 4y. So the x that we're looking for you should be able to find it by taking 2 minus 4 times the y that we're looking for. Okay. So this is the x that we're looking for. We can just take this, which is equivalent to x, and substitute it in there for x. So 2 times 2 minus 4y. That's 2 times the x value, which should be able to find that by doing 2 minus 4 times the y value, plus 5 times y equals 7. So we made the substitution. Now we're going to distribute. Subtract 4 on both sides, so let's combine these together. Negative 8y plus 5y is negative 3y equals 3, so y equals negative 1. So there's half our answer. We need to find the x value as well. Be really easy to use this equation because x is already by itself. So we can do x equals 2 times negative 4, 2 minus 4 times negative 1. So x equals 2 plus 4, and x equals 6. So 6 negative 1 is the answer. That is substitution. Okay. But I said in the previous video that we would find out what does it look like when you get no solutions, infinite solutions. So let's take a look at that. What does that look like? In the graph, if we got no solutions, that meant since the solution was found at the intersection of the lines would have to not intersect to get no solution. And then if you got infinite solutions, it was because the lines were right on top of each other. They were exactly the same. So what does that look like in an equation? Number 5 is 6x minus 2y equals 5. Negative 3x plus y equals 7. So let's see, and it's a substitution method. So we have to do substitution method. I see here that y is by itself, so if I add 3x to both sides, I'll have y equals 3x plus 7. It was just easy to use this one to solve for y, so we can substitute this in for y. And the other one, you cannot substitute it back into itself. You'll get nonsense back. Okay, I guess not nonsense, but it just won't work. So we're going to put it into the other equation. So we get 6x minus 2 times our substitution for y, which is 3x minus 7. That equals 5. 6x minus 6x plus 14 equals 5. So 6x minus 6x is 0. Plus 14 equals 5. So 14 equals 5. Now, 14 does not equal 5. We know that for sure. So what are we supposed to make of this? If we go back here, back where we had a variable in our equation, remember we're trying to find an x and a y that works in both of these equations. Okay, and by making the substitution, we're saying that this, once we solve for x, that will be the x that we need. So imagine what x value could you possibly put in here, in for these x's, so that the equation will be true? Well, no matter what you put in for x, they will both get multiplied by a 6 and a negative 6, and they'll cancel each other out. They'll always cancel each other out and come out to be 0, and we'll always wind up with this 14 equals 5. And this 14 equals 5 is never true. There's no value of x that you can put in here that will change this result. The result is always 14 equals 5. So, how many x values are there that work? None of them. No x value will ever work, and it doesn't matter what y is. If you don't have an x, it just doesn't matter. So no x would imply that there's no y value that works either, so there's no solution. There's just nothing that will work. Okay. Let's do another one. See what happens with that one. Number 10. 6x minus 3y equals 15. And negative 2x plus y equals negative 5. Making sure I got that right. Yes. Okay, so we're going to do a substitution. This y is already by itself, so I'll add 2x to both sides. That makes it easy. And we're going to take this and put it not back into the equation we just used, but the other one. 6x minus 3 times our substitution for y, which is 2x minus 5, equals 15. Okay. So we keep it going. 6x, negative 3 times negative 3 times 2x is negative 6x. Negative 3 times negative 5 is positive 15. Okay, now look at this. The exact same thing is about to happen here. 6x minus 6x, 6x minus 6x, except for the only difference in this one's result is that where this was always false, this one's always true. Okay? So where there was no x in here that could possibly make this true, it's like there's no x that doesn't work. Any x that you put in here will work, and you just can't foul it up. If you put in 17 or you put in negative 1,000, it's always going to be true. The equation will always work out. 15 always equals 15. So if there's any x value will work. If any x value will work, that means that there are an infinite number of x values that work, and by extension, there's an infinite number of y values that works. Now, that doesn't mean that you can put any x and any y and it will work. What it means is that there's an infinite number of x's and y's, or pairs, ordered pairs, an infinite number of ordered pairs that will work. That x and y will work in here and in here. There's an infinite number. If we don't have to find all of those, we just have to know that since this came out to be true, there's an infinite number of solutions. So this came out to be false, and there were no solutions. And this came out to be true, so there were infinitely many solutions. There's a lot of solutions, and in fact, there's infinitely many solutions. Because this came out to be true and this came out to be false. So false, a false statement at the end where the variables get eliminated but you get a false statement is no solution. Where your variables get eliminated but you get a true solution is an infinitely many solutions. Okay. So there you see those two examples, and now we'll do the same kind of a thing with elimination. Now, if you take a look at number 16, I altered 16 just a little bit, and that's the one that I used in the intro video. And I altered it in the same way that I'm about to alter number 17, or I guess in a very similar way, maybe not exactly the same way. Okay. So in the intro video, that was just perfect, that the y values would have canceled each other out if we added both equations together. But that's not the case here. 3x, if we were to add both of these equations together, these guys wouldn't eliminate each other, and neither would these. But we're not too far off. If we look at say the 6 and the 3, 3 is just half a 6. So if I multiplied this by 2, I would have 6. They would both be 6, but that wouldn't be good. That wouldn't be enough. We would need a negative 6 to cancel out with this x. Okay. Or in other words, if we had negative 6x and then a y, and then a number on this side, then we could add both, add this to whatever this is, and cancel out the x, and that would be great. And we can do that by multiplying this by -2, the whole equation multiplied by -2. So this gives us our -6x. This -2 times -4 is going to be a positive 8y. And this will be a positive 20. And we can definitely do that because you can do whatever you want to an equation as long as it's the same on both sides. So now we have this equation and this new equation, and we can add this equation to that one. And when we add 6x and -6x, we get 0x. Okay, so 0x. And 3y plus 8y is going to give us 11y. And 20 minus 42 is going to give us -22. And y will be -2. So y is -2. That's half the answer. We need the x value as well. We can plug this -2 in here or here. Even we could plug it in here if we want. Doesn't matter. So let's do 6x plus 3 times -2 equals -42. 6x minus 6 equals -42. 6x equals -42 plus 6 is going to be -36. And x will be -6, divided by 6 on both sides. So the solution is -6, -2. Okay. So, kind of going back through that, if we had started out with these two equations right here, that would have been great. We could have just added them together and canceled out the x's and been on our way. Just before that, though, we don't have that to start with. We had to get that from this other equation. If we just multiplied this by -2, that would create the -6 that we need to eliminate this positive 6x. And that's just the added step. We'll do that again in another example here right now. Number 18. For x minus 3y equals 10. And 8x minus 6y equals 20. All right. So we want to, again, eliminate. Well, we're going to have to mess with this a little bit, and I'm looking at 8x and 4x. This 4, if we multiplied it by 2, would also be an 8, but we needed one of them to be negative, so we'll multiply this whole thing by a -2. That way we'll get -2 times 4 is -8x, and these will cancel out. That's exactly what we wanted to do. The -2 times -3 is positive 6y, and -2 times 10 is -20. So now these two equations, this one here and this one here, when we add them together, they're going to cancel each other out. So 8x minus 8x is 0. And -6y plus 6y is also 0. And 20 minus 20 is also 0. So everything got canceled out. Everything became 0. We get 0 equals 0. Okay, well, 0 is equal to 0. That's true. So it would seem that it's like you can't mess this up. 0 is always equal to 0. So there's an infinite number of ordered pairs that we can put in for x and for y in both of these equations and make it work. Now, that doesn't mean that any x and any y will work. But we could find one solution, we could find a second solution, a third solution, we can find an infinite number of solutions. All right? So there's an infinite, or we could say infinitely many solutions, just to put the same wording as we used before. Infinitely many solutions. So if everything gets canceled out, the x's and the y's and the numbers, and you get 0 equals 0, this is going to give you the infinitely many solutions. Okay? And what does it look like then when we get no solutions when you're using the elimination method? Well, let's find out. Number 23. This one's going to give us no solutions, and I think you will see pretty clearly why that is. 18 and 6x plus 8y equals 18. Alright, so we're looking for an x and a y that are the exact same, that we can plug into both of these equations and have both equations work out. We're going to use elimination. So we're going to eliminate, I think, let's see. Make sure I wrote this down right. Okay, it's all written down correctly. And we want to use elimination. So this 3 is, you just need to multiply it by 2 to get it to 6. But again, we need to multiply it by a negative. One of these needs to be negative, so it gets eliminated. So negative 2. So we get this new equation, negative 6x minus 8y equals negative 36. All right. So 6x minus 6x is going to be 0x. 8y minus 8y is going to be 0y. And 18 minus 36 is going to be negative 18. So 0 equals negative 18. Well, that's never true. There's no way that 0 will ever equal negative 18. And since x and y get eliminated, there's just nothing we can do about that. No matter what we put in for x and y, we will always get this statement 0 equals negative 18. And that can't be. That definitely is false. Always. So there's just no fixing it. There are no solutions. Okay, so it just comes back to the basic statement. If you come down and you get a false statement, 0 equals negative 18 is a false statement, there's no solutions. If you come to the end and you get a true statement, like 0 equals 0, then you have infinitely many solutions. Okay, so that's how that works. It works exactly the same way it did before. And we'll just do a couple more. The catch here is we're just going to choose whatever method we want, whether it be substitution or elimination. So we'll do a 32. All right. So we choose what we want to do. Now, personally, I am almost always going to choose the elimination method. I see here's a negative y. It wouldn't be too hard to get y by itself and do substitution, but I don't know. I just don't like it that much. I like the elimination. It's just a personal preference. So I'm going to multiply this equation by 2 so that I will get a negative 2y, which will cancel out with this positive 2y. So our new equation is going to be 2 times 3x is going to be 6x minus 2y. And 2 times negative 2 is negative 4. So 6x plus 5x is 11x. We've eliminated the y, and 15 minus 4 is 11, and x would be 1. And if x is 1, let's find out what y would be. We could just plug it into, say, this equation here. So 5 times 1 plus 2y equals 15. Subtract 5 on both sides, so 2y equals 10 and y equals 5. So our solution is 1 comma 5. Okay, so I chose a method, and there it is. There's the answer. There you go. All right, let's do a last one, a word problem number 56, having to do with the county fair. So an adult pass for the county fair is $2 more than a children's pass. Okay, so maybe we could somehow use that information to write an equation. So an adult pass is $2 more, is $2 more. We're going to add $2 to something, to the cost of a child's pass. Yeah, so a child's pass, you add 2 to it, and you get the cost of an adult pass. So that's an equation that we could use. 378 adult and 214 children's passes were sold, and the revenue was $2,384. Wow, okay. So a bunch of tickets were sold, and $2,384 was made. I think that was the right number, yeah. So, say you are the one who's responsible for adding or to count all the money that was made, and apparently all you know is something about the number of tickets that was sold. You know that 378 of them were sold, and 378 adult tickets were sold, and 214 child's tickets were sold. Well, you know that if you want to know how much you made on the adult tickets, you would just take the number of tickets that you sold, which is 378, and just multiply it by how much an adult ticket costs. And we're using A to represent that. A is the amount that it costs. So that's how much you make on adult tickets, and then you want to add together with that how much you made off the child's tickets. So you sold 214 children's tickets. So 214 children's tickets times however much the child's ticket costs will give you how much money you made on the child's tickets. And you add this to the amount you made on the adults, and you have the total amount of money. So now we have two equations that we can use to solve for how many or how much does an adult ticket cost. Well, to me it looks pretty straightforward that A, that the cost of an adult ticket is equal to C plus 2. So I could this is already solved for. It's so easy to just take this and substitute it in for A. Use the substitution. Okay. So I said before I would almost always use elimination method, but it's set up so easily. You might as well just go ahead and do substitution. Okay, so we have 378C plus 756 plus 214C. Okay, let's put together the like terms, 378 and 214C. $592C plus 756. We can subtract 756 on both sides. So 2384 minus 756. 1628 equals 592C. Divide by 592 on both sides. 275. That's how much a child's ticket costs, but the question in the book says how much does an adult ticket cost? Well, we said at the beginning if you just take the child's ticket and you add $2, you'll have the adult ticket, so the adult ticket would be $4.75. And that's what the question is asking. All right, thanks for watching.